Okay, looks like I should be live here. Apologize for the rough start. My first stream, so I'm not really. I'm just trying to figure it out as I go here. Got to get my windows size so that I can see, so that you guys can see everything. Just working on making sure I get everything into view here, because it looks like my windows are a little too big. I'm not able to actually stream my full monitor size because I'm trying to stay to 720p, because that is the most I can get out with my limited internet connection. Out here in the middle of the desert, our skies are nice and dark, but you pay the price with limited bandwidth on the internet. So, okay, looks like I'm getting pretty close to where I need to be. Pretty close. Just trying to get all the windows in, and then I can get everything resized to this one window. As soon as I can figure it out, I have to resize it and wait for the stream to catch up to me so I can see the result on my monitoring computer. But I think I'm pretty close now. Well, anyway, good evening everyone from the Death Valley region. We've got a beautiful night here. Surprisingly enough, the smoke has subsided, at least in this area. I think they're finally getting some of the storms, some of the fires out. So we're actually getting some relief from the smoke finally after a while. So, okay, I think that's probably going to be about right. That you guys can see now all of my SharpCap screen. So now I just need to get Stellarium in here and size to about the same size, and then you'll be able to see everything going on there too. Okay, and first thing I should start off with is what I'm using. So let me get a picture of my setup out here so that you can see that. And so this is basically what I'm using here. It's a 6-inch imaging Newt on a Celestron AltAz Evolution AltAz mount with my homemade, sturdy, trusty homemade tripod, and I got a ZWO ASI 178 camera in it. And you can see the star sense also hanging on the side there, so it self-aligns, which I find just really cool. Saves me a lot of time setting up, and works really well. So, so yeah, that's my setup there. And so tonight we're going to be looking at some of the last of the summer jewel box before it sets down too low. It's almost getting a little bit too low for my skies, so I've got some decent horizons, but not infinite. So anyway, I've already got the scope set up and focusing set and everything. So now I'm just going to it's already on Lagoon. I'm going to start with Lagoon because it's the lowest target and the first one to set. So, going to start there and start some stacking on it here and see what we can see tonight. Yeah, that's not too bad. Actually, I think I'm going to bring that up just a little bit. So we'll go back to a second here, and I'm just going to touch that upward a little bit. Bring it up just a little bit more. So we got a little bit centered better in there. And we'll try that. Get started on stacking some of the Lagoon Nebula. Yeah, that's pretty good. That's pretty good initially. Okay. So, start the live stack. Put this out of the way. And, why is it saying it's paused? Okay, that's the old one. Got it. Okay, and we'll see what it comes up with here. I'll let that stack for a few frames. I'll use F11 to go full screen and kind of get SharpCap out of the way there. So you can kind of just see what the camera would see. And we'll let that get a few frames in here. Pretty nice start already though. Still kind of looking like the screen is not the right size. Oh, I see. Oh, I see what, yeah, okay, of course it isn't. Yeah, okay, I see what it is. Yeah. No, that works. That works pretty well. We'll let it get a number of frames in here. And then we will start adjusting the histogram a little bit. And there's different schools of thought on where to put the histogram. Some people like moving the black zero level to the left side of the curve, to the right side of the curve. I tend to like it right on the kind of right dead center. If you keep going to the right of the and by the curve I mean the white curve, which is the luminescence curve, as opposed to red, green, and blue curves, which control the colors. And I kind of like it more or less right along the middle. If you go to the right of it, it darkens the background, but it also darkens everything else. If you go to the right of it, it lightens everything. I kind of like keeping it right in the middle, or so. And to fine adjust, you hold down the Shift key. And just kind of adjust the histogram a little bit. The midpoint is that's really the one that makes the most impact. And then you throw a little color adjustment in here and see what that does. Looking pretty good. Here, actually, I forgot to turn on enhancement. And let's turn on the FWHM filter so I'm not getting any kind of crappy frames. And we'll try that. Let that stack up a little bit. Oh, and I know another thing I'm not doing. I forgot to add in my darks. I just created a fresh set of darks here, so I need to throw those in there as well. In fact, because I forgot to put the darks in, I'm going to have to restart this stack. Because the dark frames actually pre-process the each of the individual frames as they come in. And I'm also going to want to name this as well. So I have to undo the full screen and rename it, and then clear the stack. And now, because of a weird little bug in SharpCap where you can't name it after the stack has already started, but Robin Glover, the person who makes the software, he's already on it. He's already going to fix it. So he's looking at it. Alright, so now we've got it named, and we've got darks applied. So now we should be able to. And now all of a sudden my FWHM has gone crazy again. It was just doing really good, and now all of a sudden it's not doing so good. Don't have any clouds in the sky, so I'm not really sure why that would be. But let's see what happens. But the FWHM filter is very handy on this, because if a sub-exposure does come in that's smeared or blurred, or the mount happened to move while it was being exposed, and you get a lot of a blurry frame basically coming in, that automatically rejects it, which is very handy. If a cloud moves over, a little cloud moves over temporarily at what you're shooting, it will automatically reject those frames, which is really handy, because then you don't need to worry about crappy subs getting into your overall stack and ruining the whole stack, because you've got one or two bad frames that are causing stars that look like eggs, or blurry or smeared or anything like that. It's a very handy little filter. So we'll let this get several frames in, and then we will do some histogram adjustment on this. It is interesting doing these live streams, because what I see, I'm controlling the scope and the stream and everything on one computer, and then I'm monitoring on the other computer. I'm looking at the live stream in the other computer, basically what you guys are seeing, and that way I can monitor any chat that comes in. And go ahead and say hi in the chat if you feel like it. But I can monitor the chat as well, because when I'm on the other on the primary computer, I can't really see the chat or anything like that. So the only thing I can see is what I'm doing, SharpCap and that kind of thing. So controlling the scope. But what's interesting is that when I look at what's coming through on the stream, it actually looks much darker and cleaner than what I see on my control computer. So I can actually overdrive it and make it a bit overstretched on my computer, and what I think looks too overstretched and too blown out actually comes across in the live stream pretty nicely. So just interesting how that works. Thanks, Richard. I appreciate it. Nice to know you're out there. Yeah, I've been doing EAA for, gosh, probably about 1.5 years now, and it is a learning curve. But and by EAA, of course, that's electronically assisted astronomy, put using a camera instead of an eyepiece where you put your eye up to the scope. And it's basically, you doing this it's shown me everything that I've wanted to see for my whole life and couldn't see. I've owned a number of scopes over the years. My parents bought me my first scope when I was a teenager. I think it's a fairly common story. And you know, it's been an on and off hobby of mine my whole life, and I mean, I love it. But every time I look through any scope that I've owned, you know, faint gray stuff is still just faint gray stuff. And it wasn't until a year and a half or so ago when I got my first camera and learned about EAA that I'm finally able to see things the way I want to see them. It's been amazing. Cameras not only help you see way more than you can see with your eye, but they also help cut through light pollution, which is something that a lot of people have to deal with, and a lot of people don't bother to do much astronomy because they're in too much light pollution in their backyards. And so cameras with especially light pollution filters and things can really help with that stuff, and they can help you see so much stuff right from your own backyard when you can only see, you know, a few dozen stars yourself with the naked eye. So it's a growing field of astronomy, and it's not much more expensive than just buying regular equipment. You know, regular eyepieces and things like that to use in a scope. Instead, you just buy a camera. But yeah, I've really enjoyed it, and so now I'm kind of starting to share it with others through live streaming. And the nice thing about using a camera in a scope is you can share these views, and so that's what I'm up to now. Looks like we're coming in pretty well here on Lagoon. No, actually, Richard, I'm not using any filters. This is just actually, I'm not using anything in this. I have a 6-inch f4 imaging Newtonian, which means it's designed for photography use, and so I don't really need to use any filters here. I'm kind of in the middle of the desert, so light pollution is not an issue for me here. I have what are called Bortle 2 skies, if you're familiar with that scale. Basically, it's pretty dark skies, and so I don't need light pollution filters or anything like that. And because I'm using a reflector, not a refractor, I don't need to use an IR UV filter because I don't have any refracting elements. So basically, this is just no filters, no reducers, no coma correctors. This is just 2 bounces. The photons make 2 quick bounces and go right into the naked sensor. So this is kind of just raw, coming right in with no filters at all. In fact, that's one of the reasons why I use the ZWO ASI 178 camera. It's a 1/2-inch censored camera, and one of the reasons I don't go to a bigger camera sensor is because then you start using the more outer reaches of the curved mirror that's in the bottom of the Newtonian telescope, and you get what's called coma, and and then you start having to use coma correctors, which is another large optical device you have to put in your eyepiece so it's in the optical train, and you just start having to add more stuff. And I like keeping it as simple as possible, and so I just keep it at the smaller sensor and don't have to use anything in the scope in the way of correcting refractive elements like reducers or coma correctors or field flatteners or anything like that. And the images stay pretty clean. They stay pretty good. So where about in Georgia are you? Well, I have a brother who actually lives in Cumming, and not sure where that would be in relation to you, but might be nearby. He moved down there from Maine, where he lived for a lot of years, and he really likes the Atlanta area. He's really liking Georgia. Even though it's quite a bit warmer than what he was used to, he's really liking the climate. So, sounds like a pretty nice place you guys got down there. Normally I let things go for about 10 to 12 minutes or so. I kind of let them cook. But it's coming along pretty nicely now. And where are we? Yeah, see, now we're getting good numbers again. I don't know why it went so high before. Anyway, that's good, that's good, that's good. Yep, alright, we're doing pretty well here. Okay, so you're a bit south. Cool. You got a good astronomy club. Do you have decent skies where you are? I know you're probably more humid in your part of the world than I am out here in the desert, but still, if you get dark enough, you can see a lot of stuff. Let's see here. I might actually move this a little bit further right than I thought I would. See how that works. But you can see all the nice dark lanes in there, and the dark spots that you can see in here are Bach globules, I think they're called, and they're different little formations that are in here. I actually don't know a whole lot about this stuff. I'm learning as I go, but you know, for me, I just love looking at these wonders. But there's a lot to be learned about this stuff. I mean, there's just so many facets to all this. Oh, and guess what? So it looks like my FWHM filter has gone. Oh. Let me take a look at my stack, because I may be, let's see. Let me see if that one's not very good. Well, that one's all blurry, so that's why that's not coming in. I may actually be starting to hit a roof line, and so I may actually have to move off this target. That may be as much as I can do, because I think I'm actually hitting my roof at this point. So that's probably about as good as we're going to be able to do on this one. But I think it came out pretty well. And I'm just going to save that right now, and we're going to move up to the next target, because I have a feeling I'm in my roof line. So we'll just save that. And we will bring our window back here, and we will stop our live stack and reduce our time and see if we can go up to our next target, which isn't too far away. It's going to be the Trifid Nebula right above. So we will head up there and see if we can snag that one. Alright, let's stretch our exposure and see if we can't find this little guy. Okay, yeah, right down here, right on the bottom here. So let's bring him up into the picture here. Kind of bring him up into the center. And we'll see what we got there. That should be about right. Yeah, you can kind of see right in here. Okay, let's see. Turn that stretch off and go to our full 16-second exposure, and hopefully we'll get this in there. Although actually I'm thinking this might also be in the roof. I think it actually is. Okay, yep, we're already too late for this one. Darn. Okay. Yep, I've lost the whole bottom of the frame. Okay. Well, then, let's jump up to the Omega Nebula. Let's synchronize on Trifid and now head up to Omega. Head on up to Omega and see if we can't see where that guy is. Let's see, I'm still not seeing him. Where are you? Ah, bingo, dead center. Okay. I will undo this stretch and redo that stretch. That should bring him in. This will be the Omega Nebula. Bummer that we missed Trifid. Had to get on that faster, I guess. Okay, let's start a live stack on... Oh no, actually no, wait a minute, I don't want to do that yet. And this is going to be Omega Nebula. Okay, and now we'll clear the old stack. Clear Lagoon out of there and let some frames come in, see what we can see. Get the program out of the way there. Just watch a few frames come in. With every frame that comes in, the bright parts get brighter and the dark parts get darker. And so with the noise with each frame that with each 16-second sub that comes in, the noise drops away and the image gets clearer and brighter. And it just continues to smooth out and get better and better with each one of the little sub-exposures that comes in. Did I add my dark? I think I got darks going. Where are we? Yeah. Yep. 16 second, 31. Yeah. Yep, dark is applied. You can see that it looks like we got a satellite roaming right across roaming across the image, which happens now and again over the course of the next several frames. It will get averaged out and will disappear, but satellites definitely do happen when you're looking up at the night sky. They seem to get more and more numerous as time goes on. Alright, let's bring our histogram stretch back to the peak again. let's yeah, the color. The color adjustments are art, not a science. There's two different stretches you can do with the colors, and I just kind of roughly bring them in and then kind of tweak them myself. But hi Pat. Yeah, the color balance, I don't know. It's I guess you just kind of do it to taste. Do we actually know exactly what these things are supposed to look like? I don't know. No matter what we look through, it's always seems to be filtered by something, our atmosphere or something. I guess depending on the chemical compositions, we should. The more hydrogen, the more red it is. The more oxygen, the more blue or green. So, I don't know. The color on these 178s is always a little interesting anyway. It's kind of a game you play with them. While this stacked for a couple minutes for any of you guys who showed up late, I show you what I'm using tonight. It's a 6-inch f4 imaging Newtonian on a Celestron Evolution mount, AltAz mount. That's a fairly simple and easy to set up mount, which I like. And you'll see on the side there's a star sense actually mounted to it, a smaller camera, a little black camera on the side there that's mounted to it. And that's not what I take images with, that's what auto aligns the scope so that it aligns itself, which makes it quicker and easier for me to set up, which I really like. And then in the top part where the eyepieces go, I have a camera stuck in there. In this case, a ZWO ASI 178 color camera, and that's what I'm using tonight. And the 178s are really designed to be planetary cameras. I'm not really using it for its intended purpose by shooting DSOs with it, but I really like the resolution. I'm kind of I sacrifice a lot to get higher resolution. I really do like it. I like being able to zoom in on things and not have it be all pixelated and whatnot. I like having the extra detail to look at. With the small pixel cameras like the 178, they make that really happen. But the price you pay is lower sensitivity, and even in the case of the 178, some color balance issues that can be a little wonky sometimes, but I like it. It works for me. It certainly gives me something much more than I could ever see in the eyepiece, which is kind of my litmus test. So I really enjoy using them. And I could go to a more sensitive camera, but would have to sacrifice some of my resolution to get it, which is not something I generally like doing. So but this is coming in pretty nicely. At about 8.5 minutes now. 8.5 minutes of total exposure time. It is weird doing these live streams when you're the only person talking. I sometimes do my streams on Night Skies Network, which is nightskiesnetwork.com, and you can actually do live chatting there between people, so there's actually a number of people who can chat together, and it's just a different experience where you're the only person chatting. Especially for a person like me who's normally not a very talkative kind of person, but here I just get to yammer on by myself. Let's see, maybe I can push this stretch a little bit more. Yeah, not coming in too badly. There are certainly newer cameras that have a lot more sensitivity and could pick up a lot more of the wispiness and stuff that are up above this, but like I said, I'd have to sacrifice my coveted resolution to get it, so I tend not to do that. I think it's coming out pretty well. So all this stuff in this area seems to be about 5,000 or so light years away. All these nebulae in here, which is only about 20% of the distance between us and the center of the Milky Way, which is the direction that these are in, generally speaking. So, just some interesting stuff, kind of in our neighborhood of the Milky Way, really. Okay, I think that's good. We got about 12 minutes on there. That's about right for this. So let's head on up to Eagle and see if we can't catch that before it sets behind my roof. Let me center this up and get this a little bit better centered in my view. And then we'll move on to the next target. Get that centered in there a little better. use that to synchronize Stellarium. And then head up to Eagle. Just a short little hop. Up to Eagle and see what the Eagle has for us tonight. Yeah, there it is, right in there. It's actually pretty good, probably right where it is, so let's unstretch this one. Redo that one. Go up to our 16-second exposure. The approximate FOV. It's a little under half a degree wide by about a third of a degree tall, I believe is what this gives me for a field of view. Alright. Okay, and we're going to get Eagle, Nebula, and then clear that. And that's cleared. And we'll start a new stack on the Eagle. Oh, you can already kind of see the Eagle right in there. Bring that in a little bit. Well, let's let it get a few frames on. Let it pull several frames in, and then we'll see what several subs in, and we'll do the histogram on it and stretch the histogram and try to bring it up a little bit. Alright, let's see if we can bring in a little bit more of this. A little bit more, and we'll try an initial color stab here. Kind of make it pop a little bit more. But you can really start seeing this nebula's namesake, the eagle right in there. That dark patch looks like an eagle in flight with its wings raised. actually don't know much about this one. See what Wikipedia has to say. About the Eagle Nebula. Eagle Nebula, or M16, also known as the Star Queen Nebula and the Spire. It's a young open cluster of stars discovered by Jean-Philippe de Chazot in 1745-46. Both the Eagle and the Star Queen refer to visual impressions of the dark silhouette near the center of the nebula. Right. An area made famous as the Pillars of Creation imaged by the Hubble Space Telescope. Wonder if we can get in and see the pillars. Wonder if we have the resolution for that. Nebula contains several active star-forming gas and dust regions, including the aforementioned pillars. Yeah, the diffraction spikes, I don't know. I think they actually kind of look cool. I don't know if that's because traditionally photographs have looked that way or not. I don't know. I think the stacking definitely does have an effect on it. The histogram stretch, I think, also has an effect on it. Just part of the noise. The more you keep, the darker you make the background, the more those kinds of elements will also go away. That's why I like keeping it on the peak. But I don't know. I think they're kind of cool, so I kind of leave them mostly. Gotta get in there and really see. Maybe I'm missing them. I'm not seeing the pillars. Might not have the resolution quite yet. See if a little more stacking can't. Can't get in there. The Hubble, my telescope, is not. But it does okay. And like I said, I just have to keep in mind that my litmus test is really me comparing to what I can see through the eyepiece, and you know, for me, that's just the cameras just are outstanding. I just love using them. They allow me to see so much more than I could ever see. On my own. Oh, I see. Okay, no, okay. Yeah, I get it. Okay. These actually are the pillars. Okay. Now I see what they're so these three formations here, this one down here, this one down here, and this fainter one here, which almost looks cloudy, in a higher resolution image like you can get from the Hubble. That's what these are called. They're called the pillars of creation. And they also form the eagle shape here too, which is how it got its name. But yeah, these. So I see now from the Hubble images where these are showing up. So these are the pillars of creation, what are called the pillars of creation. Yeah. So you can kind of see this one here is actually one piece. It's kind of cloudy, a little bit cloudy and whatnot. It's kind of hard to see. I don't know if zooming in is going to just make it too grainy, but who knows? On the live stream, it's interesting because when I look on the live stream, it looks better than on my own screen. So who knows? But yeah, these are the pillars of creation. These three things, these three formations here, kind of this bottom piece, sort of tying them together. But this up here is the third pillar and the largest one, and so it's sort of a cloudy looking, lighter cloudy looking one, as opposed to these that are much darker. But those are the pillars. On the stretch, maybe darken things down just a little bit. Bring the sharpen up the contrast just a little bit more. Gotta bring those pillars just a little bit more contrasty on those. Kind of a cool nebula. According to Wikipedia, this is 5,700 light years away. So what we're seeing right now is how this existed 5,700 years ago. What it looks like today, we will have to wait 5,700 years to find out. Time for some juice. It's pretty cool because the longer you wait, the smoother and better it gets. Just a question of how patient you want to be. I think I like it back the other way. And then a little bit more pressure on the stretch this way. Yeah, we're actually starting to get some of the dark formation in the big pillar here. I almost kind of see it as one contiguous element, although we do have one bright star right here that kind of obscures part of it. It's kind of mushing into it a little, but coming along kind of nice. This whole Sagittarius, Scorpius, Scutum area of the sky is a pretty rich, dense area. Again, because it's the center of our Milky Way, so we're looking to the heart of our galaxy, which is just loaded with all kinds of riches. Just giving this some extra time to see how good we can get the pillars to come in. See how far in I can zoom before it gets grainy. It's probably about as good as it's going to get. So I think we'll just save that as is. And see what we can do next. Shrink this back down so we can see where we're going. Drop our exposure back down for the same reason. And let's see, right now if I'm looking up, yeah, so we're kind of almost all this stuff now at this point is pretty much gone. I don't know that I can see. Now M22 is gone. I think M25 is going to be, yeah, it's pretty much gone. So we're probably just going to have to get right up and out of this region. So let's head up into Scutum and see what we have to offer up here. Got some star clusters up here. So we could try a star cluster. Send the scope to it and see what we can see for a star cluster. Kind of the big, bright, exciting stuff is now set for the most part. And we can do a few other bright, shiny objects. A couple of planetary nebulas or something in a bit, but for the moment, we'll just maybe do a couple of open star clusters. Yeah, there we go. That looks pretty good. And let's get a dark in here that uses our 8 seconds. And this is, what did I say it was? M26. M26. Alright, let's see what this little star cluster has to offer. Clear out our eagle. And let this grab a few frames to see what we get. Nice little open cluster. I tend to do open clusters with about an 8-second exposure because they tend to be a bit brighter than nebulae, which have fairly faint surface brightness. Star clusters tend to be quite a bit brighter, so I usually do about half the exposure with them than I do with nebulae and stuff like that. Alright, we'll give this a few frames to come in. Already can see different colors in all the stars. See what Wikipedia has to say about M26. M26 open cluster in Scutum, discovered by Charles Messier on June 20th, 1764. 8th magnitude cluster. It's a challenge to find with typical binoculars, but it can be spotted with an 80mm aperture or a camera with almost anything. It is positioned near the open cluster M11 and is 14 arc seconds across. About 25 stars are visible in a telescope with a 6 to 8 inch aperture. It's about 22 light years across and about 5,200 light years from Earth. 22 light years across, which is not much in terms of stellar distances. An interesting feature is a region of low star density near the nucleus. A hypothesis was that it was caused by an obscuring cloud of interstellar matter. But a paper by James Cuffey suggested this is not possible and that it really is a shell of low stellar space density. But there is, as of yet, no clear explanation as to why. Oh, that's interesting. Unusually low core density, and they don't know why. Who knows what could be between us and it? Let's see what else. M11 is another one. Yeah, we'll try M11 next. It's not a whole lot 2-star clusters, so it doesn't usually take very long to pull them in. Just usually 3 or 4 minutes. Usually does it about right. So we'll just save on this one and head up to M11. Do another cluster real quick. Alright, turn off the stacking. Go back down to our cruising exposure here. Back to Stellarium. Got 11 selected, so let's just send the scope. And there it is, right there. Big as day. Give the scope a minute to settle down here. Yeah, that's a good cluster right there. Alright, try stacking on this. Oops, I gotta do this first. 11. Boom. Okay, now we'll clear. Now we'll clear this and see what we get. Clear this, clear that. See what we get with a couple minutes of stacking. Much denser, certainly a much denser core, which I guess from what we read on M26 is more normal. wild duck cluster is what M11 is also called. Open. It was discovered in 1681 by Gottfried Kirch. Its popular name derives from the brighter stars forming a triangle which could resemble a flying flock of ducks, or from other angles, one swimming duck. A triangle, huh? The cluster is located just east of, Scutum star cloud midpoint. It's one of the most richest and most compact of the known open clusters, which I guess is kind of the bridge between an open cluster and a globular cluster, which is a much more, it's a very dense ball. One of the most massive clusters known and has been extensively studied. 870 members of at least magnitude. Let's see, I don't think it says, does it say how far away it is? Where are you? No, not really. The cluster is located 6.8 kiloparsecs from the galactic center. Well, I'm not seeing exactly the triangle of flying ducks, but that's how it got its name. Still, it's a pretty cool cluster. Have I done the color? I don't think I've done the color on this. No, I haven't. Yeah, well, sort of. Bring a little more red. Not seeing a whole lot more color. I'm not seeing a whole lot of color in this one, like in the last one. The last one had, M26 had more colored stars. You can definitely see more yellow and reddish stars around it, but the cluster itself seems to be much younger, whitish, bluish stars. I think they said it's only 316 million years old is the estimates for its age, which in terms of stars is pretty young. But it's a pretty cool looking cluster. In a pretty rich, dense field. Star east of the, so it's just east of the Scutum star cloud, which is this, I guess, this formation here. This chunk of the Milky Way that's poking through this star cloud here. Which is why we've got such a density of stars in the background. And still, even with that, this really pops. Red light trying to go out here. Yeah, it's more than enough on that, I think. So we'll save that one. And then turn off our live stack. Anything else interesting in the area? Star clusters. Cygnus has a lot of cool stuff in it. It's up pretty high. Probably a bit higher than I want to go, though. But we can certainly try shooting for the Ring Nebula. Alright, where are you, little ring? I have my... Whoa. Why are you not typing? Ring Nebula. Right there. There you are, you little guy. Alright, we'll send the scope off to the Ring Nebula. It's in a nice spot in the sky right now. Okay. Don't see it immediately. Ah, there you are. Alright, bring you down into the middle. Call you good enough there. Synchronize you on there. Alright. And go back to our 16. Actually, sometimes I do this at 16, sometimes I do it at 8. So, we'll see. 16 sometimes can blow it out a little, actually too much. So we'll see what we get here. Yeah, see, 16 is going to be too much, so we're going to go back to 8. Get the right darks on there. With the stacking, 16 is just a little too much. Okay, this is going to be 57, which is the Ring Nebula. And we'll clear this stack. And let that get a few things on here. Let's reset this. Let it get some subs in. Let it pull a few subs in and we'll see how well we can see it. This is a planetary nebula, one of the brighter planetary nebulas in our sky. And you can still see the central star in it. Tiny little dot right in the middle. Which is the star that's lighting it all up. the nebula itself is gas and whatnot that the star actually blew off at some point in its life cycle, probably near the end of its life cycle. Blew off a whole bunch of its gas and matter, and blew it all outward into space, and didn't go out, so it's now illuminating it all. Yeah, it's coming along. Yeah, just gotta blow it out. Let's see if we can add a little more color in here. Really start to see that central star now. In the area here, there's also a really, really faint galaxy. That you have to blow out M57 to see. I have to use high exposure to see it. It's right down in here. It's IC 1296. It's a very faint little galaxy that's right near, right in the same, close by in the field of view. It's obviously not close by the Ring Nebula, but it's in the same field of view. But in order to be able to see it, I have to really blow out the Ring Nebula, which is much, much brighter. Can't really quite even see a faint trace of it right now, but I think it's down in here. Yeah, just barely down and to the right of it. Yeah, so it's going to be right down in here somewhere. And once I get done stacking that, I'll try stacking a little bit on the try doing a 16-second exposure. See if we can actually see it. It's pretty darn small. Pretty small and faint. But we can see if we can pick it up. It'd be better off with the mono camera. Galaxies don't tend to respond as well to color cameras as they do to mono cameras. But let's see if we can't try for it at least. Yeah, right now, Richard, I'm doing 8 seconds on the Ring Nebula. If I do 16 with the stacking, it just blows out a little too much. And so, to get the ring to show up nicely, like it is right now with the central star, you can see kind of right in the middle there. I keep it limited to 8 seconds, and but I want to see if I can see IC1296, which is a faint galaxy right down in here. So once I get done with this stack, I'm going to try increasing to 16 and see if I can pick up that galaxy in here. It'll completely blow out the ring nebula. It'll just be a blown out mess, but I want to see if I can't pick that up. Yep, that's going to be next. Yep, I'm going to go to 16 to see if I can't pick it up with this. Like I said, with the color camera, I'm not sure that I'm going to be able to get it or get much of it. On another night when I have the mono camera in, that's the galaxy hunting camera. That one's much better for finding those kinds of things. I can actually kind of start seeing a couple of other things in here. Another star or something, which I suppose could be a star in the background or the foreground. Another light patch there. Kind of neat. Never saw those little details before. But I think we got a pretty good stack on this. So let's see if we can't save this off. And let's just start another stack. Let's go to 16 seconds with our 16-second arc. That is what I'm, yes, yes. Yep, 16-second arc. And then we will restart this. Restart all of it and see if we can't see a little 1296 in here. Let's see if we can see it at all. What is the 6? Oh, it's a mag 15. Yeah, that's pretty darn dim. Usually I can't go much below mag 13 with this particular setup, but it should be somewhere in here, somewhere between this bright star and the ring nebula. Should be in here somewhere. I don't know that we're going to be able to see it. I'll let it stack a few things here, but really the Hi Joy. You flew to Costa Rica tonight, huh? Wow. I don't think that's actually what you did, but okay. Let's see. I'm not really seeing it. So I don't think it's actually going to come in. Now, I think we need the mono camera to pick up on this. Pretty soon you'll be saying hola from Costa Rica, but not quite yet. Yeah, I don't think the galaxy is going to come in. I'm really not seeing even a hint of it here. Am I? No. No, I'm not really seeing much of it at all. So, I think we're going to bail on this. Go check out the dumbbell. Dumbbell's a good one to go look at. It's a fairly bright, shiny thing, which is what my color camera specializes in. Bright, shiny stuff. Alright. Yep. 1296 is not going to happen tonight. So, let's go over to dumbbell. Did I do... yeah. Oh, the live stack. Why didn't the live stack stop? Guess I didn't. Okay, so that's going to be... yeah, alright, let's back out of Lyra. And... wow, where did all my... wow, okay, all of a sudden all of my symbols have disappeared. Okay, well, we'll just find it the manual way. Why have all my symbols disappeared? Somehow labels and markers got turned off. Don't know what that's about. Anyway, all set now. Alright, let's head over to the dumbbell. And see what we can see there. And zoom out so we can see the whole field of view. Well, let's see if we can find our little guy there. Oh yeah, right here, just a little faint patch right there. Let's bring it into the view, into the center. Yeah, that's not too bad. Maybe up just a titch. That's about right. In fact, while we're there, let's sync them out. Alright. Go out to 16 seconds. Undo that stretch. And see if we can't see our little dumbbell nebula, aka apple core nebula. There we go. That's a nice start. Clear that one out. Yeah, I need to do this. Delete to go. And clear again. So because I can get the name in it. And you are already reset. So let's pull in a few subs on the dumbbell nebula, which is usually a pretty darn good one for this setup. Nice and bright and shiny. Actually, while this stacks for a minute or two, I'm going to run in and get into a pair of sweats, because it's actually starting to get a little cool for my shorts and t-shirt here in the desert. Probably down under 75 now, so starting to get a little cool. So anyway, I'll be right back. Well, you can watch this stack in the meantime. Okay, that's better. Let's see where we are here. Brighten things up a little bit. And do a little bit of a color jump here. Yeah. That's looking pretty decent. Stretch it a little more. See how that goes. Getting some nice detail in that. It's another thing in a pretty rich star field. It's kind of in the path of the Milky Way, which also looks like it got shut off. Huh. Somehow a bunch of things have gotten shut off on here. I don't know how or why. Night mode, center on, blah blah blah, deep sky, planet labels, atmosphere. Labels, use outlines. Sky. Atmosphere, stars. Okay, there, now it's back. I don't know how this stuff got turned off. Somehow while I was cruising around in here, it got turned off. And also, below the horizon has been turned off too, which is normally on. Well, I guess I've got some... The stars limit, use designations, markings, yeah. I'm not sure that section. Huh. I don't know. Somehow it got turned off. I'm not sure how. Somehow a bunch of settings just turned themselves off. Oh well. I'll have to figure it out another time. In the meantime, we got our dumbbell filling in nicely here, our apple core. Good night, Richard. Thanks for stopping by. Glad you enjoyed yourself. It's coming in nicely. Yeah, it is pretty nice looking stuff, isn't it, Joy? It's amazing how pretty some of this stuff is. The red for the hydrogen and the blue for the oxygen makes for some pretty cool, spectacular looking stuff. All the result of a big old explosion. This was the result of a supernova, I'm pretty sure, if I remember that correctly. I think this one is a supernova. I have to look that up, be sure now. No. Dumbbells. It's a planetary nebula. About 15,000 years old. It's a white dwarf, so looks like it's not the result of a supernova. It's just like the ring, ionized gas blown off the star, and the little white dwarf star at the center, which presumably is this one, is lighting it all up. It's coming in pretty nicely. I guess the question now is what to see next. Anybody have any suggestions? Feel free to write them in the chat. Cluster associated with nebulosity. I suppose we could try that. Good night, Joy. Thanks for stopping by. Good to see you. Sleep well. That's probably about it for this one. So we'll put this one away. Alright. Turn off the live stack. Put us back down. Let's see if we can see any of this nebulosity. Surface brightness of mag 14.5. That might be a little faint for my setup, but what the heck, we can give it a shot. Well, it's red, so that's hydrogen rich. So that's what it's supposed to look like. Guess we'll find out here. If I can pick it up with this little camera. And I'm pretty sure this is it down here. So let's see what we can see. Bring it into the center a little bit. Relax that stretch. See if we can pick anything up on it. What is this? NGC 6823. 6823. Yeah, we'll see the cluster. The question is, will we see any of the nebulosity? It's pretty faint. But we'll stack a few. We'll stack a few things on it. I'll run a few subs and see if we can see anything. to see much nebulosity in there. Not looking like there's going to be much there. Yeah, it should all be in here. I'm not seeing it. Well, hard nebula. Oh yeah, that's a really, really big one. Yeah, with a really low surface brightness, so we'll be able to see that. That's what I thought. Cocoon. Cocoon is a possibility. And we could go try the cocoon. Not too far away. Yeah, I don't think we're going to get anything on this. This one's not going to happen. Let's go try the cocoon. I don't think I've ever tried imaging the cocoon. So let's see what we can see on that one. Down, stack is off. Let's send the scope over to the cocoon. It's going to be real high. Yeah, it's 80 degrees. Well, we're going to get a lot of field rotation on this. It's not in a great spot to see, but let's see what we can see. Alright, let's see if we can pick it up here. Not seeing it. Let's see if we can pick it up at all. No, I'm still not seeing it. So let's try plate solve. See if we can't find it. "35 stars found." I'm seeing a lot more than 35 stars. But I think it's seeing this view. Alright. Try 8 seconds and see what it finds. Forget what I've got my plate solver. I think I've set it to bin too. Reached maximum magnitude star base. Huh, okay. Plate solve just completely failed. Never have been able to get ASTAP working correctly. I don't know why. Sometimes it works, sometimes it doesn't. And I am not seeing anything here. I'm just not seeing it. Okay, well, we'll try 16 seconds, but if this doesn't work, I'm just not seeing it here. Nope. Oh, wait a minute. Is that it? No. This might be it up here. Might be it up there. Let's bring it down here a little bit. Okay. Yeah, it's right there. Okay. Let's reset this stretch. And this is going to be cocoon. Alright, we'll clear that. Let's see if we can stack a little of the cocoon in. I've never done this one before. Let's see if we can't pick something up out of it. Hmm. What do I have this set for? Downsample of 2. Try to downsample of 3. Okay, and then save. Alright. Yeah, I'm not picking up anything here. Let's seem to think this was okay, so let's pick up this and see if with a downsample of 3 ASTAP will work. Just to confirm I'm on it. I think I am on it, but now it's complaining the downsample is too high. Never have been able to get this. A lot of people rave on it and rave about it, but it has never worked reliably for me. Astro Tortilla may be slower, but it just works. And this has never given me anything but problems. Let's see if this one works. It doesn't complain about the downsample, but it doesn't solve it either. Yep, fail. Fail, fail, fail. Well, I'm going to assume I'm on it and I just can't see it, so I don't know what else to do. With a mag of 7 and a surface brightness of 12, I should certainly be able to see it, and I can't find it. So I'm not sure why I'm not able to find it, but there you are. Well, okay, let's try another method. Let's go to a nearby star. Synchronize on that star and make sure we're on it. Okay, well, let's... Well, is that the right star? I'm assuming it's the right star. Gotta assume it's going to be close. Wow, boy, did that overshoot by a long, long way. Okay. Let's go back. And go back. And go back. That's going to be pretty close. That's too much. Okay. Alright. Well, we're going to assume that is dead on. Then we're going to put it there. And let's go back here and see if that local synchronization will help find it. I'm not seeing any recognizable star patterns in here. Huh. Well, let's try doing a plate solve again. Only 22 stars found. How are you seeing only 22 stars? That doesn't even make any sense at all. Okay, well, this is a bust. I don't know why I can't find this. I don't know why the plate solve isn't working. But obviously, I cannot find this object, so moving on. Let's try M39. Nice bright cluster. See what it does with that. Okay. Yeah, Don, I'm not sure. But I mean, people rave about ASTAP, I know, and I have nothing but problems with it. I don't understand what I'm doing differently from other people, but it just does not seem to work for me. Okay, let's see. Fairly loose cluster. Let's see. No, it just does not work. Now, it seems to me I still have AstroTortilla installed. So, I'm going to try and... No, it isn't. I uninstalled it. See, now I'm not able to... Now I'm not even finding this. It's a pretty loose open cluster, though. But still... Well, Deneb should be pretty darn unmistakable, so let's try that. And it's not even in the view. So obviously our pointing is way off here. Okay. AstroTortilla is on this machine. Let's see. I know I have it. Where is it? I know it's on this machine. Okay. Software. Tortilla. I'm just going to reinstall it because this ASTAP just does not work. And I am just done fighting with it. Whatever. Shouldn't take very long. It's already been installed, so it should not take long. Huh, I don't remember this install taking this long before. Okay, so well, I may have to pull the camera out and use an eyepiece to actually align this. I'm not sure why this is yeah. Try giving it a few more stars. Astro Tortilla always takes a little longer, but it always solves. Of course, now of course it's going to fail. Okay, and I have a feeling it's going to fail because it's overstretched. So let's try this. $1,848 sources. How is it finding 1,848 sources? There's only like 20 stars in the frame. Wow. Well, I've never had both of them fail. That's interesting. Huh. $1,656 stars. That makes absolutely no sense at all. Well, this is just getting ridiculous at this point, so I think it's just time to call it a night. I have no idea what's wrong. I don't know why neither plate solve is working and why they're getting such crazy numbers. Plate solve always works for me very, very reliably, and tonight it's just not working. And I don't know why. and I'm clearly way off my target and don't even know what direction to go in. So I think I'm just going to end up calling it a night here. I don't know what else to do. I forget what it did. It tell me to increase or decrease the sigma? I don't remember. Found 1,834 sources. That doesn't make any sense. Try increasing the sigma value. Okay, increasing the sigma value. Alright. To what, I wonder? Try increasing it to 70. See if that does anything. Wonder why it's picking, now it's 1,200 sources. Wonder why it's picking up so many stars. Doesn't make any sense. Okay. Go to 100. With only this few stars in there, really shouldn't be picking up. Now it's down to 930. That, I think, is usually a number. Well, it still doesn't make any sense. It's picking up way, way, way too many. What am I doing wrong? What? Huh. I don't get it. Probably about right. Huh. All right. Well, anyway, I think that's going to be about it. So I am going to simply end the stream because this is just going nowhere. So anyway, thanks everyone. I'll see you next time.